Hi, welcome to the mathcenter.com. In this video, we are going to look at, I plan to look at 3 questions, but I realized one of the questions has lots of words on it that you can actually handle it on yourself. But let's get through the other 2 questions. They are objective questions or multiple choice questions, if you like, which appeared on the recent AS Physics exam 9702/11, May, June 2020. So we want to start with question number 8 and then move on to question number 9 and 10. Let's see how we keep some good timings with this. Yeah. Okay. Before that, please share this video as much as you can and give me a like and follow me on Facebook and YouTube. For details of the courses that we run in the mathcenter.com, please visit my website and you'll have lots of details there. Okay. Okay, question number 8. I have sort of paraphrased the question here, the important things. There's a car which is accelerating from rest. Yeah? There's a car accelerating from rest. Important, the word rest, in a straight line, and constant acceleration. So which means, before we read anything else, never mind, let's read the question first. What are we asked to do? We are asked to pick out from a series of graphs they have given us in A, B, C, D, whatever. They have given us a few graphs and we want to pick the right response. Let's not worry about that. Let's talk about the problem. Yeah? So we want to plot a graph of momentum P against S, the distance traveled. Okay? So we want to plot a graph of momentum P against S, the distance traveled. I guess you can look at it from quite a few viewpoints using unit dimension analysis and so on. But let's do it. Let's discuss it. Yeah, let's discuss it. First, we have the fact that when you have a car accelerating from rest, okay, straight line constant acceleration. So we can think of it like this, okay. And if we are sketching V against T, okay. So from here, we know that U, because it's accelerating from rest, you know U is 0. So we know V equals to AT. Yeah, remember it's U plus AT, right? So U is 0, so it's just AT. And you're told that A is constant. So we can write V is proportional to T. Okay? Now, having said that, we also know that S equals to ut plus half at squared. Now, if your U is 0, then S equals to half at squared. But you know A is constant. Therefore, S is proportional to T squared. Okay? All looks good so far, right? Proportional to T squared. Therefore, T is proportional to the square root of S. Settled. Now we've got all this out of the way. We also know that momentum is mass times velocity. The mass is constant, so we know that P is proportional to V. Mass is not changing. So what we said earlier, that V is proportional to T, so that we can write P is proportional to T. And we said that T is proportional to S. Therefore, P is proportional to, let me say it again. We said T is proportional to what? The square root of S. So P is proportional to the square root of S. So which means we have P equals to K. Sounds good? Yep. So let me write it here. So let's square it. So it's P squared equals to K squared S. Therefore, P squared equals to AS. What is A? Some constant. Not important. Yeah? So P squared. So this is like Y squared equals to, so this equation now is like Y squared equals to 4x or something. And we have a graph like this. No, this is P against S. So we're done. So the correct response will be A. Okay. So I thought it's a pretty interesting question. Let's leave question number 8 and let's move on to number 9. Yeah. Okay. One other way you could have done number 8, you could, instead of using all these proportionalities, you could have maintained the A and then still worked out the problem. Nothing to worry. Yeah. Okay. Question number 9. Let me read the question. Yeah. Question number 9. The resultant force on a raindrop of mass m falling in velocity v is given by F equals to mg minus kv squared. Resultant force on a raindrop of mass m, okay, where k is a constant, g is the acceleration of free fall. What is the velocity of the raindrop when it reaches a constant velocity? Yeah, constant velocity, constant in brackets terminal velocity. Not hard to do, yeah. So they ask you for the, hang on, let me read that again. They ask you for the velocity of the raindrop when it reaches a constant velocity. Okay, that's fine. Okay. So constant velocity, terminal velocity means what? Your acceleration is 0. When the acceleration is 0, what does this mean? Your resultant force, okay, your resultant force is 0. Therefore, we can write mg minus kv squared is 0. Therefore, kv squared equals to mg. Therefore, v squared equals to mg over k, and v will be the square root of mg over k. And that gives you the correct response of C. So, question number 9 is pretty easy. Yeah, pretty easy. Except that you have to know that when you have constant velocity, you know that, yeah? Constant velocity, your acceleration is 0. And when your acceleration is 0, your net force or your resultant force is 0, and then we are done. Question number 10 is a textbook thing. So, a stationary toy gun fires a bullet. Okay. Let me just write it here. We have okay. We have a gun and the bullet. This is before. A stationary toy gun fires a bullet. Which statement about the bullet and the gun immediately after firing is, careful, right, is not correct? Okay, which one is not correct? Which statement is not correct? Yeah, which statement about the bullet and the gun immediately after firing? So, when you look at the responses, you will immediately realize that response D is not correct, because response D says that the kinetic energy of the gun must equal the kinetic energy of the bullet. No way, yeah. Okay, when you fire, okay, we've got the gun and we've got the bullet, yeah. Their kinetic energies will never be equal, yeah. Okay, so correct response for number 10 is D. The rest of it is all textbook stuff. The rest of the responses are all textbook stuff. You can easily look it up. You don't need me for that. Okay, thank you very much for watching. Please share as much as you can. Give this video a like and follow me on Facebook and YouTube. Good luck on the exam, right? Just take your time, read the questions carefully, approach, use the right principles, and you'll be fine. Okay? Do not lose your confidence. Thank you very much for watching.